Okay, I think we'll go ahead and get started. Happy Halloween Eve to everyone who celebrates it. As if my face was not scary enough, Red Canary was generous enough to make these hilarious Zoom backgrounds for us. So props to our graphics team. Always love that stuff. Hey everyone, my name is Matt Graber. I'm the Director of Threat Research at Red Canary, and we got Mike here.
Hey everybody, good to see you all.
So today we're going to be talking about atomic test harnesses. So what is this thing that we're going to be talking about? So it's a new open source project that our team, the threat research team, recently released. And I think it's helpful to talk about what some of the problems are as defenders and detection engineers, and to then talk about why we created atomic test harnesses to attempt to chip away at addressing some of those more fundamental problems around detection. So we've all likely been asked, the defenders among us, and even red teamers for that matter, have been asked the question, how do we detect a certain technique? And I don't know about you, but like that question is always initially intimidating to me, because typically my perception, at least, is the answer that the person is wanting to hear is a confident yes, like a binary yes or no question, like either you do or you don't. But there's so much nuance included in that. So to just say that we absolutely detect technique X, what the heck does that actually really mean? So something that's very near and dear to Mike and I is the concept of detection coverage, right? So those of you with some development background, you're probably familiar with the concept of code coverage, right? So if you want to be confident that your code base is relatively free of obvious bugs, you can start to gain that confidence if you know that you've maximized the test coverage of your code. So if you have tests that exercise all of the code that you've implemented, so not only the code paths that you expect to run under normal circumstances without exceptions, but also those exception cases as well. Wanting to maximize that coverage gives you that confidence. Now, again, those of you with a developer background probably know very well, just because you've maximized your code coverage doesn't mean that you've eliminated all the bugs, right? And that is absolutely the same case with detection and detection coverage. So what we're going to show you is atomic test harnesses is just one way in which we can collectively increase our detection coverage. But even with that confidence that we've sufficiently increased our coverage to an arbitrary number or scale or percentage, it's never going to be a perfect solution. But fortunately, like we think at least that whenever we do miss anything, because we have this framework, which we'll show you, we can easily extend it to when we do encounter a miss, or say one of our customers reaches out to us and says, hey, like, what the hell, we see a false negative here, like you missed this actual attack. Like, I mean, yes, we're a vendor, like, but we're all fallible humans, and like there is no sense of perfection in security. So there are the occasional misses, and what's important to me and to Mike and us in general is it's what you do with those misses that really matters, and how you can use those misses to educate and improve your overall security program. So without further ado, let me share my screen and hopefully try to make some more sense of putting these concepts of detection coverage into practice. All right, so First off, where do you get atomic test harnesses? Two main places to get it. You could get it straight from our GitHub repo. So it's just Atomic Test Harnesses under the Red Canary Co. Organization. Another really easy way to get it is with every release that we publish, we'll publish it to the PowerShell gallery, meaning you can just run this. So if you were to run that, hit enter, it would automatically download it from the PowerShell gallery and install it in the appropriate place such that you can be up and running without having to screw around with anything else. If you did want to install things manually, it's certainly up to you. One way you could do it is just by, well, you could either clone the repo or just download as a zip file. And then once you've unpacked that, then you could just manually import it by calling import module and then just specify the path. So I'm already in the Atomic Test Harnesses directory. I'll just hop out of it real quick. And then what you'll be importing is the PSD1 file. This is the module manifest file. And it's easy as that to install and then to import into your PowerShell session. Now, if you go this route or you install it to your proper module directory, which this takes care of automatically, you won't ever have to type import module unless you want to be explicit about it. Okay, so what all is included in this PowerShell module? So the thing that I'll do most often when I'm installing a new PowerShell module that I'm not familiar with is after I import it, I'll call get command -module and then module name. And then it will show you all of the explicitly exported functions or commandlets in a module. So we're starting relatively small right now with the technique coverage that we have. Obviously, 3 techniques out of the 500 plus now sub-techniques that there are is a drop in the bucket. But we wanted to set a relatively high quality bar from the get-go as we gradually introduce new attack techniques which exercise as many variations of that given attack technique as possible. All right. So the scenario that we're going to use here is Mike and I have been tasked with improving our detection coverage for MSHTA or HTML applications, which if you're not familiar, obviously you can, I didn't have it handy, but let's see if I have it here. Oh, it's fine. Well, you could just go to MITRE and there's a dedicated sub-technique for MSHTA. So you could get a little bit of background on that, see how some attackers are using it in the wild. Going to the MITRE site is always like one of the best first steps. Now, you're never going to get like the full context of like what are the technical components that comprise this attack technique that we need to ideally have a robust detection for. And it's not going to enumerate every conceivable instance in which the attack technique has been abused in the wild. So that's really incumbent upon people like Mike and myself. When we go through our research process, it's incumbent upon our intelligence team to give us a heads up as to how threats are actually using these techniques in the wild. And we get to use all that as input into the implementation of these test harnesses. So the one that we implemented as we concluded our research into HTML applications is Invoke ATH HTML application. You'll see the this ATH prefix consistently in our functions. It's a PowerShell best practice to have those function prefixes. So it's an abbreviation for atomic test harnesses. So that's what that is. Okay, so let's get a little more information about the HTML, or sorry, the HTA runner. So I'll just run get-help or help on that. Get a little bit of initial information here. Now, all of the functionality that we expose is going to be thoroughly documented. So I'll always start by just reading the brief synopsis of like, okay, what is the essence of what this thing does? And what we'll also be consistent about in the synopsis is having the MITRE technique ID listed in there. So now in the syntax area, you can start to get a sense of all of the variations that we support. Now, you're going to hear us talk about the concept of variations quite a bit. So we refer to them internally as technique variations. So MITRE, you may know, has sub-techniques now, which has been incredible for us in the interest of reducing the scope of our work so that we can be a lot more tactical and more confident in our coverage for a more narrowly scoped technique. Now, just because you have something as a sub-technique doesn't mean there's also going to be additional variations upon that sub-technique that may or may not have entirely unique detection logic. And so that's kind of the bar that we'll set when we consider what a technique variation is. So let me be a little more specific now about, like, in the case of HTA, what we consider some of these technique variations to be that we want to have coverage for in our code. So one example is you can supply an HTA file on disk to mshta.exe. And within an HTA file, you can have embedded script code. So specifically Windows script host code, meaning things like VB-script and W-script. So attackers abuse this all the time. So that's coverage that we'll want to have. The ability to execute quote unquote malicious HTA content from a file on disk using mshta.exe. Some other variations might be the fact that you can just have mshta.exe reach out to a URI, download HTA content, and then execute it. That's abused all the time in the wild. We want to support that as well. Some other interesting options that are supported, which we've also seen in the wild, is the fact that you can supply inline HTA code instead of needing to drop it to disk, right? So you're starting to see that with these variations, there may be potentially unique detection logic, which we're going to want to account for, and we're going to want to be able to automate because, I don't know about you, but considering all these variations and with all the ways in which like an HTA file and the HTA content and the script code embedded in it has to be formatted, like, I'm fairly comfortable with HTA now after having gone through this exercise, but I don't like, I'm not going to be able to remember how to do all that manually. It's time consuming and it's error prone. And so that's really a call to action of like for every test that you do manually, ideally that should be at least one test case that you can automate away completely and not have to worry about doing manually. Further documentation that you'll see here, if you add on TechFull, is you'll get detailed information about all of the parameters that are supported. So this is actually one way to learn more about HTA and all the variations that are supported. For example, like we found through the course of our research that all file extensions for HTA files on disk, like it doesn't matter what the extension is, with the exception of if Windows interprets the file extension as having a MIME type of text plain, because in that case, it's just going to display the script code and not actually execute it. And so that was interesting for us in order to be more confident in our coverage of potential file extensions when it's file extensions that we care about considering for our detection logic. We want to always make sure within reason that we are shattering any assumptions that we might have going into this. And that's how like our whole research process plays into this. All right. You get documentation about the output. All of these functions will output a fairly detailed object giving you contextual information about what executed. And then wrapping up the documentation, you'll have examples of everything. Okay, so at this point, having gone through all the documentation, we should have a fairly good idea of how to start poking around with this and start executing some things. So let's go ahead and dive right in. One thing that we'll strive to do is to have default behavior where no arguments are supplied to each function. And so like for the sake of just getting up and running as quickly as possible, we wanted to support that scenario. So I'm not going to pass any arguments here, just hit enter and let's see what we get. Note there's a little box that popped up. That's the MSHTA window that you may have noticed. And let's just go through all the context that we get. So with every test runner that will be introduced in Atomic Test Harnesses, you're going to get at least these three properties as output. You're going to get the relevant MITRE ATT&CK ID, or the technique ID. You're going to get whether or not the test succeeded. And there's a fair bit of complexity that goes into this test case returning true. And I'll get into that in a minute. But in short, when test success is true, that means that the underlying technique and subsequent payload that executes communicated back to the test runner to indicate that, yes, indeed, I did execute. Because in this case with MSHTA, it's one thing to execute MSHTA.exe at the command line. It's another thing to actually confirm that the script code within the HTA content executed successfully. And in this case, that's what that true tells us, that the script code actually executed as expected. Now, if you happen to be responsible for like an overall detection, like testing pipeline in your organization, this is something that might be relevant to you. So if you wanted to use these test harnesses as like a glue between executing a technique and then the subsequent validation of the technique, you could use the test GUID property to uniquely identify the test that ran. So that's just how we expose that and uniquely identify that, uniquely identify this particular test as this particular test with that randomly generated GUID. All right, so all of the properties that follow are going to be specific to the test harness at hand. In this case, these are all going to be relevant to MSHTA execution. So you can read up on all the documentation of like what all of these properties actually mean, but perhaps we could just try to infer a little bit of what's going on. Maybe let's just jump to runner command line, right? So we can see that MSHTA executed with an HTA file that was supplied on disk. And we get the relevant process ID. Like this is something as a detection engineer for validation purposes, I'm definitely going to want to know. So we try to expose all relevant telemetry that a detection engineer or threat hunter would want to know. And we strive to not go completely overboard with things and just give you at least what we feel is going to be the most relevant information for you to base subsequent decisions on. The runner file path is something we expose. In the case where HTA content is supplied on disk, we give you the actual path to it and its file hash. We give you the script engine. Now, because HTA code can embed Windows script host code, the Windows script host comprises a handful of different scripting engines, one of which is JavaScript or JScript. And so that's the default that we'll use. But as you'll see, we can override pretty much everything here. And the execution type is file. So what we're trying to communicate here is what the relevant technique variation is. So we're talking about HTA execution where the HTA quote unquote payload is a file. Now, we'd also like to get some information about the HTA payload that ran. And so in a lot of our test harness code, we're going to have a template payload that executes. And in many cases, what you'll see is the template payload that executes. So like the JavaScript code in the HTA file is going to spawn a child PowerShell process. And you'll see this pattern often of write host GUID. So this is like sort of the glue layer that we have between payload execution and the test runner. And we have some eventing code in there that says, okay, like you need to look for a process that has this GUID, which is just a unique value in the command line. And if you see that process start event occur, then you can be confident that your HTA payload actually ran. And hence, because we're seeing that, we expect that, then we can actually return true for this test running successfully. Okay. So now let's put our attacker hats on for a little bit and consider, let's assume that defenders or vendors that we're going up against are prone to introduce relatively naive or brittle detection logic. Okay, well, let's think about some things that as attackers, because we already have code execution, some things that we would have direct control over that might circumvent that otherwise brittle logic. So I can think of a few things already. For example, like, do we actually need to run MSHTA from the System32 directory? Could we relocate it somewhere else? Could we rename MSHTA to, like, I don't know, notepad.exe? What about the HTA file on disk? Like, one, do we have to drop it to disk? Or if we choose to do that, do we have some control over things like the file name, the path, and the extension?
Yeah,
So these are things. Yeah, go ahead, Mike.
Sorry, I was just thinking too. Even the script engine, right? Like
Yeah.
we might, as defenders, we might focus on a particular mod load occurring, whether it's like JScript DLL or VBScript DLLs loading,
Exactly.
or on the command line with like an inline execution. So,
Totally. Yeah, and that's a great point. So I did want to show you all the content of the like template HTA that we generate on the fly. And when the default is supplied, the script language in the HTA code itself is going to be populated with JScript. Right. So as researchers, like we're good. Well, as researchers, like defensive researchers, but also like evasive attackers, we're going to want to ask ourselves the question, like what other scripting engines might be available. So like to Mike's point, like, I mean, I think that's like pretty good logic potentially to identify, say, a suspicious process that loads JScript.dll that otherwise shouldn't be loading JScript.dll. But in that same breath, like as an attacker, like we could say like, oh, haha, like, well, I can just change the script language. And so that naturally raises the question, what is the set of script languages that as attackers make sense for us to be able to supply in order to carry out our objective of executing malicious code within an HTA script. Okay. All right, so what else can we supply here? We can do script engine. Now, everywhere it makes sense to do so in these test harnesses, we try to support tab completion. So you see, like I could just start doing script. You already get this tab completion for free in PowerShell. Where we need to go above and beyond is in like if there is a certain set of values that we only want to accept. For example, there's a finite set of script languages that Windows supports. And so you just tab through all those, the ones that we decided made sense for us to support because they made the most sense for attackers to leverage. Now, when we were going through this, like we were kind of surprised. Like, I know like we had heard of like the encoded ones, but like personally, I hadn't really seen it used too much in the wild. And so like this being kind of a novelty and like relatively unique, we just want to make sure that we could support it. So let's go ahead and use that as an example. Actually, I'll come right back to that, but let's just try to change all the things and just like do a Hail Mary here. So I'm just going to copy to this temp directory I have. And I mentioned notepad.exe, so we'll just call it that. Okay, well, let's just go one step further. We'll call the executable text.text. Oh, wait, no, we can't do that. No, we can do that with the executable. We can't do that with the HTA. That's documented.
Correct, yeah. It was in your screen earlier. You showed that.
Yep. Okay. All right. So MSHTA is being renamed to text.txt because why the heck not?
Yep.
Okay.
Attackers do it all the time, I hear.
Oh, sure. Yeah. Okay. All right. What else? So yeah, we're going to change the script language. We're going to change the path and the file name. While we're at it, let's just go ahead and change the file name of the file name and extension of the HTA file, knowing that we can't set it to .text. That's a limitation of HTA. All right, so script engine, VB script, no, script engine. Okay, MSHTA file path. We should just be able to give it that. Now the HTA file path, we should be able to just give it a file name and extension, foo.bar, whatever. Yeah, let's try that. Look at that.
Nice.
Okay, so we got some context here. We noticed that the relevant things that we supplied as arguments are now surfaced as the output of this test run. So we can easily validate what exactly happened. So we have our script engine that was used. We have the full file path of the HTA content and its file hash. We have the path of the executable, quote unquote. So this is mshta.exe, just simply renamed. Windows lets you do this just fine. And then the full command line and the relevant process IDs. All right. The template payload hasn't really changed. Because we want to validate that the test succeeded, we still kind of need that template payload in there. Now you probably saw me screw up a little earlier when I started doing -script content. You can supply your own script code as well. We want to give you the option of supplying whatever quote unquote payload you want to carry out your test. We'll just have no way of automatically validating that your script code ran. Right. So this is the scheme that we use in our template payload to validate that. And so that's the only way that we can surface true. Otherwise, if you supply your own script code via -script content, it's just not going to return true, and it's going to be up to you to validate that. Okay. For giggles, let's just look at the contents of foo.bar, because I'm intrigued by what vbscript.encode looks like. So
yeah,
pretty
this
neat.
is cool. It's awesome because, like, you know, as defenders or whomever's using Atomic Red Team, you have more options and visibility to be able to, in a safe way, more or less, to go and run HTA content, use MSHTA, review the content that's being generated with it. And there might be script engines in here that maybe you haven't even really seen in live fire, but now you're going to be extra curious to go generate new detection content for that.
Exactly.
Yeah, I think onto your next one here is again just options and visibility for all of us to have, you know, in one place. Yeah,
totally.
go for it.
Yeah, it's like with those alternate script engines, like you and I don't care that we don't necessarily see evidence of them being abused in the wild, but because through our research process we were able to see that they can be supported, we wanted to be able to support those in code, so that we can really maximize our confidence that we can, yes, indeed see the technique of MSHTA being utilized, independent of how we see MSHTA actually being abused in the wild.
Yep. Yeah, excellent example is like the moved and renamed MSHTA. You know, depending on the tools you have or the things you're using, you may or may not be able to detect that move or rename, which hopefully you should be able to, right? Just depending on the products you're using. But yeah, it's gold.
Yeah. Okay, so let's just look quickly at one of the other variations. In this case, we're going to supply script code inline on the command line and not worry about dropping, quote, malicious code to disk. Right? Like with many of the other examples, we support tab completion where it makes sense. And so let's see what protocol handlers are available. Okay, so those of you who may be a little more intimately familiar with HTA tradecraft, you may have only seen JavaScript and VBScript abused in the wild. That was certainly the case for me when we first went into this. But then one of our detection engineers, while we were going through this process, reached out and was like, hey, like, do you know about the about protocol handler? I was like, well, no. And turns out like there was an attacker actually abusing this in the wild. And so again, like this process is not perfect, but him giving us that heads up allowed us to dig a little deeper into, like, first of all, like what the heck are these protocol handlers? Which ones does Microsoft support, and what do they do? And once we learn what they do, then we can more confidently assess which specific protocol handlers actually buy attackers in the wild. And generally speaking, like if we're talking about like MSHTA being like a lull bin, what we're looking for to buy an attacker is further code execution. All right. So what are some of the options we have available to us? So we have, yeah, let's just go with that. See what that looks like at the command line. Okay. So again, like at the time, this was completely foreign to me. So we had to make sense of like what this about protocol handler is for. And the tricky part too was figure out how to format this properly such that it would actually execute what we wanted at the command line. So there's a lot of like escaping involved that we had to take into consideration. So let's see what some of the other supported ones would look like.
I like that warning.
Yeah. Cool. Okay. Yeah, so just another example here. Oh, that's right. Yeah, the warning makes sense to me now.
Yeah.
Like the script engine, when you're supplying a protocol handler, VB script is implied that the script engine is VB script. Yep. And because I got caught not realizing that that was an assumption to make, I then quickly turn around this warning just to give you a heads up about that. But it's still going to run anyway. It's just going to ignore the script engine in that case because you're supplying VB script there. So, okay, last cool thing I wanted to show, and we cannot take credit for this. There's a great blog post on using HTA for lateral movement. So HTA in its implementation is exposed as a com/decom object, meaning that you can remotely instantiate instances, more or less, of HTA, right? So I wish I had the link handy. Maybe Brian or Haig, you could post that in chat.
Yeah.
But we wanted to wrap that awesome functionality really well because when we ran the proof of concept code from that blog, we noticed some very interesting attributes. So we'll switch this up and just do simulate lateral movement. And let's observe the difference here. So the primary difference is, well, there's still an HTA file path that's being executed, but it's not being supplied at the command line. So attackers are probably thinking, yay, like we have this great potential evasion, right? Maybe, not necessarily. Like at this point, this is like our job as detection engineers to make sense of mshta.exe-embedding, like if that is an expected legitimate thing to occur or not. Ideally, it never legitimately occurs in most environments, or if it does, it's rare enough that you can tune it out. Either way, because it's a variation that has been established, we needed to be able to support that in our code so that we could independently and in an automated fashion make that assessment on our own. All right. So kind of wrapping this up, as you can see, the permutations that you could supply via all of the different arguments that could be supplied can quickly explode and be a relatively large number, right? And I'm certainly never going to want to like manually validate that we have coverage for all the different script engines when supplying a file path, all the different protocol handlers when HTA script code is supplied inline on the command line, when you're using that com lateral movement tradecraft, right? So this is definitely a case for further automation. And one way in which we test all of those things without having to think about it all in one go is using PowerShell's built-in testing framework called Pester. And so what you'll find is every time we release a new function in Atomic Test Harnesses, we're going to have test code that accompanies that in the form of this suite of Pester tests. So no need to worry about the implementation of all this. I encourage you to go read this if testing with Pester is something that you're interested in. But real quick summary of what we support is we'll have a basic suite of just unit tests just to validate, just to make a best effort at maximizing actual code coverage in our code and making sure that we're exercising all of the exception cases that we've covered in our code. Really, this is primarily just to make the code more resilient in general, but also resilient against refactoring, which we have to do on occasion, just a fact of life. the set of tests that you'll probably be the most interested in as defenders and detection engineers are the technique tests. And so all of these tests have tags. And so if you just want to execute certain tests, you just supply the specific tag. So you'll see that for any test that's related to MSHTA, you just supply the MITRE technique ID as a tag. And then if you just want to execute technique specific tests, like actually executing the HTA content and validating that the telemetry that you expect is what was actually output, that's what these technique tests are for. And so the way we run those is by calling invoke pester. And all these rely on pester version 5 and above, because we make use of some relatively newer features.
So then do have, just real quick, we do have this, if you haven't used pester before, the pieces are broken out on the GitHub repo. I'll post that link as well, just running pester test. That's right in the chat there.
Cool. So while we're talking, I'm just gonna run this suite of tests, and Mike and I are gonna do some deeper dives on the testing methodology that we apply to these test harnesses. So there's so much that we could speak to about our philosophy, methodology, and implementation of all these tests. In the interest of time, we can't really do that, but hopefully you can try to get a sense of like this test suite is going through all of the available parameters. And for each available parameter, if there's a fixed set of arguments that can be supplied, each one of those like permutations, we want to have a test case for. And so just running this test suite can give us pretty darn good confidence that if in our endpoint products that we're testing or whatever validation process that we're testing can see every single one of these instances, then we got some pretty good confidence that we're going to be able to at least see, not necessarily detect evil versus benign, but in all cases see that HTA code ran. And with that foundation, then we can really start making more confident assessments about the robustness of our behavioral detections. So with that, I'll leave it to you, Mike, to talk about Atomic Red Team.
Quick question there on your screen.
Yeah.
Somebody who hasn't maybe used pester, but at the bottom I see it says not run 195.
Yeah.
Does that mean there's 195 more tests?
Yes. So there are 195 more tests that do not have this tag that I supplied. So if I was to remove that tag, I would execute all the tests. And so there'll be tests for each specific attack technique that we implement. And then there's also some module-wide tests that we use as like a sanity check to make sure that there's consistency in the design across all of our exported functions. Good question.
Sweet.
Yeah.
And a lot of tests.
Yeah. Cool. I'll leave it to you, Mike. You wanna share your screen?
Yeah, let's do it. All right. Yeah, so that was a lot of information. So we went through using the atomic test harnesses directly. And so what we wanted to do when we were building the test harnesses is we wanted to make it to where we can add them into Atomic Red Team and be used with Invoke Atomic. And that PR went in last week. And so now you can use all three of the test harnesses that we produced with Invoke Atomic. And so I have the PR up on the left, just kind of as a quick review of it. And I'm just going to more or less showcase what it looks like with using Invoke Atomic Red Team. So I'm going to try to keep on the left side here a little bit where we're following, just kind of following with the MSHTA T1218.005. I'm just going to pick, or kind of show here too, when I added these in and we mentioned technique variations, when you run the get help against the harness itself, you notice the 6 parameter sets. We just directly correlated that into creating a base test for each one of those. And you saw with Pester that there's quite a lot of variations. So we just took the base one for each parameter set and we added that into Atomic. And so we added 6 new tests in here, which will cover like each one, like simulating the double click, performing over UNC with that lateral, the lateral movement with decom, things like that. All of that is here now in Atomic. And it's as simple as we all are used to, which is just using the Invoke Atomic test piece. And now all I have to do is call in T1218.005. I want to, make sure I have that loaded up. And so I pulled down the latest Atomics repo. And so now I see those new tests 4 through 9 in here. So kind of your next question, right, is which one do I want to play with? Again, you can use the harness directly, or now you can go ahead and start using, Invoke Atomic with us, hitting off of that. The awesome part about this is because there's so many variations, there's different script engines, I can change the HTA file path, the MSHTA path. I added all of those as input arguments. So if you're in here and you're just, hey, I can execute the default, or I can modify it and do something different, either on the fly or generate my own new test based on a different script engine. So all of that's there, which is nicely shown within the markdown on Atomic Red Team. You can see the default inputs for test number 4, the script, HTA, MSHTA path. And then you actually see the exact attack command it's going to run. And again, it's using Invoke ATH HTML application, and you can see how it's going to format that for execution. And then if you don't have the prerequisites installed, which in this case is the test harnesses, it will go, and if you do get prereq, it will go and install that module for you, AtomicTestHarnesses. So very simple, all nicely packaged, ready to go. And now we can just go and kick off a test. I'm just going to pick, I'm just going to show the details for a test number. So I'm going to say test number 4, which we have on the left in the browser. Now I'm seeing it all written out. And this is one of my favorite features. I'm just go ahead and full screen that. One of my favorite features with Invoke was something Canary added, which was showing the command with all the inputs in there. So if I really wanted to, I could just copy and paste that, and I have it running just directly with the test harness itself. But in this case, I'm going to go ahead and run test number 4, and we'll see what happens. Similar behavior as you saw on Matt's screen earlier is the HTA will execute. You'll see the box down in the corner, all the same type of stuff. So we're really quick there, but you now get that same output showing you everything you need to know. Your test grid, your script engine, HTA, all those pieces are there for you. So pretty awesome stuff. And so all of this is built into Atomic Red Team now and using Invoke Atomic. Now, we have a couple more minutes. I'm just going to show a little bit about those input arguments because I think it's important to just see one of these things more live. So with Matt, he was showing with the harness directly changing like the script engine. With Invoke Atomic, we can tell it to go ahead and prompt us for those. So now as you're running your test, you want to say, take test number 4. I want to be prompted for those input arguments. And we had 3 of them for this. So I can change like the path more or less like on the fly. So I can say, ctemp atomic red.hta. I'm going to do VB script this time. And I'm just going to leave MSHTA from that default path. So it will modify that on the fly and run that, and the box will go real quick as it did. And then there's my output. And I have it all, my VB script, my new location for the HTA, all that in one place. So pretty cool. And then the other piece that you could do if you wanted to actually create your own code is you can actually open up the YAML and just you could copy and paste it down at the bottom, change the settings you want. It's as simple as just changing these default strings, JScript to VB script, and creating your own, submit a PR, help out if you'd like, add some more tests, at least, build these things internally, generate more as you feel that you would like to use through Invoke Atomic and Atomic Red Team. So that is that. Yeah, there's a lot of content here.
Question for you, Mike.
Yeah, what's up?
How would you describe the difference between Invoke Atomic Test and the functions that are available in Atomic Test Harnesses?
Yeah, great question. So the piece that kind of came top of mind was with this, I can actually use Invoke Atomic to remotely execute one of these on a remote system. I get a little bit more functionality with this. The piece that we didn't want to add in here was 190 tests, for instance, or 160 different tests of MSHTA into Atomic Red Team. But I could have all of these tests to execute. And that's sort of where Pester comes in to help out with the mass execution of all those different variants. So it just kind of depends how you want to run it. If you want to use with it remote, or if you just want to execute the harness locally yourself, things like that. It just all kind of just varies and depends. But I think the biggest thing is just having all the options and the modularity of the harnesses themselves, and being able to bring them into Atomic really helps.
Yeah, that's the key point there. I think bring them in as a dependency for Atomic tests, right?
Yeah. Yep.
So in the interest of wanting to improve detection coverage for Atomic tests, we can enable that in a really clean, abstracted fashion, which your Atomic tests, I think, is kind of testament to, by bringing in the Atomic Test Harnesses functionality. So
yeah,
Invoke Atomic Test is designed to invoke exactly that. Invoke Atomic Test YAMLs, like YAML documents, right? So there's the Atomic Red Team schema, that YAML document, right? And Invoke Atomic Test, its job is to parse those tests, interpret them, and execute them accordingly. Atomic Test Harnesses is completely separate from Atomic Red Team, where you saw in my demos, I had no mention of Atomic Red Team, and I ran them independent by themselves without Atomic Red Team. So if you're an Atomic Red Team shop and you're wanting to utilize what's available in Atomic Test Harnesses, you can look to examples like in Mike's code of how to pull those in to maximize the use of Atomic Test Harness functionality in your Atomic tests. So I hope that makes sense. We had one other question, which I thought was pretty good. Will there be any cleanup options, or will that step be manual? I'll try to address that for the Atomic Test Harness side. We made a decision to not perform that cleanup step. And I mean, it was a subjective decision that we made, but it came down to, in the cases where, let's say there are artifacts that are dropped to wherever, like on disk, like in this case of MSHTA, when it drops the HTA files, we supply the file path and the hash. We wanted to give the flexibility of, for any other step along the testing and validation pipeline, if required, to be able to go back to that host system and actually maybe like pull the contents of that file, validate the hash independently. And so we didn't build into atomic test harnesses the ability to take care of cleanup for you. But our rationale was because with the output of the test, you're given enough context to go do the cleanup yourself, right? So like you're given the path as in the object output to that HTA file. So you could very easily just like pipe that output to remove dash item or however you wanted to delete it. So it would take that extra manual step, but we wanted to leave that up to the user instead of making assumptions about how cleanup should be performed.
Yeah, totally.
Yeah, so that about wraps up the hour for us. So sort of in conclusion, like just want to reiterate like what this buys us, like what this buys Mike and I in the interest of gaining confidence in our ability to improve our detection coverage. And ultimately it comes down to we can be more confident in our ability to detect and distinguish between malicious and benign behaviors surrounding a technique when we have confidence that we can see that technique and all of the supported variations in the first place. And ideally in an automated fashion, again, because like us being humans, us crafting this stuff manually is time consuming and we ain't got time for that. And two, us being fallible humans, like we're prone to errors, prone to screwing up the minutia of how all these quote unquote payloads need to be formatted. So why not have automation do all of that for you? So that was the genesis and rationale behind us implementing and building upon atomic test harnesses to supplement, not solve, but supplement our overall detection improvement strategy at Red Canary. And us making it open source, we hope that you can use this to supplement your detection strategy as well and gain that confidence yourself without someone like me at Red Canary saying, hey, trust us. No, you can go test it yourself. So that was our goal with all this. So hope you all enjoyed that. We very much would love your feedback. Certainly open to potential ideas for attack techniques that you'd like to see incorporated. Can't make any promises. It's kind of an expensive process to incorporate all these features into a new technique. But we definitely love to consider that and see what techniques are really causing you headaches that you'd love to see better coverage for. Any last minute thoughts, Haig?
Yeah, I think the biggest thing is as groups are out there checking out the harnesses. I mean, there's 3 right now. Yeah, definitely provide feedback and try them out. I think there's some pieces in there that as defenders, there might be things you haven't looked at in a long time. And there's variations of these techniques that are old and possibly new for everyone. And you may end up finding something that you hadn't had coverage for in a long time or whatnot. So I think this is one of those extremely valuable projects for everybody to be able to check out and play with.
Yeah, totally. Cool. Well, again, hope you all enjoyed that. Just want to thank you all for your time, for digging into this stuff with us. Like we get really excited about this and we hope you can start getting a little more excited about geeking out about like formalizing your testing strategy for improving your detection coverage. So with that, everyone have a fantastic weekend. Safe Halloween if you're observing that, and we will talk to you later. Bye.
Bye. See you.